So I think that's it. Yeah. Okay. Yeah, doctor. So I think we are good to go.
Okay, all right.
All right. Thank you. And see. Um,
Hello, good morning, good afternoon, good evening from wherever you are joining us from. We'd like to welcome you to our workshop for this week. It's a great pleasure to have you join us for this workshop. I am Doka. I'm happy to have many of you here. And it's great as well to see that we are trying to find ourselves a seat. So please kindly just get yourself a comfortable seat and enjoy this workshop. And we are urging all of us as well, if you have not named yourself and you are still anonymous, please kindly just rename yourself. It becomes easier as well when you actually have your name. Then when you're moving around, you get to know who you are yourself and where your arrow is. We also want to remind you that if you want to move around, kindly use the arrow keys, the up, down, right, and left to move around from one seat to the other. You also have facilitators around. That is the purple and yellow seats you'd see. You can move to that area as well and seek help with a facilitator to do so. So this is just fundamentals for Python. As we build on that later, we welcome all your comments, your criticism, your suggestions to make this workshop a very wonderful one as well. We'd like to welcome you once again. For this workshop, we are very privileged and very honored to have one of the best. He is a lecturer at KNUST, the Department of Climate Science. He has actually been doing a lot of a very wonderful one as well. We'd like to welcome you once again. For this workshop, we are very privileged and very honored to have one of the best. He is a lecturer at KNUST, the Department of Climate Science. He has actually been doing our facilitator for this week, who is in the person of Dr. Jeffrey Ayer to take us through. Thank you so much and enjoy the workshop. At KNUST, the Department of Climate Science. He has actually been doing our facilitator for this week, who is in the person of Hello. Yeah, it looks like we have people waiting to join. They keep saying the space is full. Yeah, Jeff, I think our YouTube channel, the sound is not playing.
Sorry. Okay, so please check if it's on now. Okay. All right. So can we have confirmation if it's working now? Okay. All right. So I think we are good to go. So like I was saying, so with the print, the print method, you just pass your print and then you open and close your parentheses, and then whatever you want to echo or output onto your console or your terminal, you pass that in here. Now with no output, that will just produce an empty line. Okay, so if we try this, we just have a blank. All right, and think of it as the same way if I'm printing a string, because I said the strings are passed into single, I mean sort of inverted commas. So if I have this inverted comma and then there's nothing in here, there's no text, it still would produce a blank line. All right, and then we also have this approach which will produce sort of a new line which will work exactly as a blank, and we'll be looking at this in more detail. That's the backslash, and when we start talking about the string data type and then the string escapes, we'll be dealing with that in more detail. So you can try your hands on this and then on these ones and see how it works. Method that goes with the parentheses. So we have input, we open and we close the parentheses. Okay. So we have input and then we open and close the parentheses. Now think of it this way. When I request an input, it means the user would feed in an input. So this is only the PC telling you or requesting an input from you, and then you have to give it an input. But think of it this way: if I just run this, we have this sort of text box opened, and we have the cursor blinking. All right, and it's requesting an input, but there's nothing to show that it's really requesting an input, or even if the text box shows that it's requesting an input, I don't know exactly what information it's requesting. So I can pass in anything at all. All right, and it will still work. But then if you want to prompt, okay, you want to give the user a prompt that, okay, enter this specific detail or enter a detail that conforms to this, then you would have to pass that information in here as a string. Okay, so and we said strings are passed within the single quotes. Okay, we can also do same with the double quotes. So we have this, and then I would want to probably request the age of the person. So let's say enter your age. Okay, and we have this. Now if I run this time there will be a prompt, there will be a text indicating that, okay, this is exactly what we want, and then the user knows exactly what information to pass in. So maybe let's say the person is 12 years, so the person can exactly enter 12. Okay, so that's how the input method works. So you would have to pass in here what to be echoed to the user. What prompt would be echoed to the user that, okay, this is the information we're requesting, and then the user can enter whatever information he or she wants to enter. And one thing to also note is that whenever you use the input method, irrespective of what the person enters, it will be retrieved as a string. Okay, so even though we entered 12 here, you notice that the output is 12 in single quotes. So always the information that the input will collect is a string, and we'll be looking at strings in just some few cells from here. And there are ways to convert them from string into exactly the format or the data format that you would want to have it in. Okay, so we have this approach, and then also we can you know sort of assign this to a variable. We'll be looking at variable assignment in more detail as we go on. So if we prompt the user with this to enter the age, we can take that age and then give it a variable, we give that value to a variable. So let's say the variable age. It means whenever we type in age, the input that the user gave is what would show. So if I pass this to age and I run that from here, and the user enters say 14, you see this time there's nothing prompting. But then if I type in again age, we should have what the user entered, which is the 14. Okay, and so that's how inputs work. So we have another example down here. So let's say we have this as a text and it says enter a double digit value as an input. So we run this, a double digit value can be say 95, and then that is assigned to the variable text. Okay, now if you want to see what the text contains, on Jupyter Notebook you can just type the text. Okay, you can just type it and you are good to go. So let's say 95 and then it works. But if you are using some other um, you know IDEs, for instance Spider, you then have to print it out if you are working from the editor interface. In that case, you can't just type the text and then it will produce the text. You have to print text, which we've already seen the output approach, how to print the text, and then it tells us exactly what the user entered. Okay, right. So I believe we are moving at a cool pace. Let me see if we have some, you know, comments. So just a quick one. If there's any challenge, if we are all okay with it so far, I mean, we can just show by hand if we are good. All right. Okay, sure. Okay, so that's good. So I think we can move on. All right, so with variable assignments, we use the equal sign. Okay, so when we talk of a variable being assigned a value, it means take your personality. Imagine you as a human being, all right? You are a person, you are a variable, okay? And you have been assigned a value of, say, your name, all right? So whenever we call that name, all right, when we I mean, call that variable, we know the variable has this content of a name. So for instance, I want to assign, say, x a value of 2. It means x has been assigned a value of 2. So whenever we print out x, when we call x, x will come with its value of 2. Okay. Now think of it this way. You can't do the reverse. You can't assign the value to the variable. Okay. You can't do the reverse. If we try doing this, let's say we have 2 equals to x. This produces an error. It says it cannot assign to literal. That means we can't assign the value to a variable. Okay. And also, one thing you need to understand is that variables have certain do's and don'ts. You can't start your variable name with a number. So something like this. You can't start with a number. You can't start with a symbol. So let's say, for instance, dollar. You can't start your variable with this symbol. But then you can have variables that would, contain alphabets, numbers, I mean underscores, and then other, yeah, I mean underscores, yeah, at best. So we can have something like this, and this is a good variable name because one, it doesn't start, it starts with a text or an alphabet, and then it contains an underscore, it contains a number. That's good, right? Something like this is also okay. There's a good variable name, and that's it. Okay, so we can also assign a set of numbers, I mean a list of numbers to a variable. So in this case, for instance, a has been assigned a list of particular, I mean different numbers, and then we print out the a from this end, and we can see exactly what a contains. We have this other example where we've assigned class size to a value of 50. So we assign 50 to a variable class size, and when we print it out, we have exactly what value we assign to the variable. Okay. Now I talked about data type, and I'm sure somebody will be wondering what we mean by data type. So when we talk of data type, we are simply referring to, I mean, the type of data we are using. Okay. Now there's a way to identify that. So we use the type method or the type function. And like I said earlier, when you ever enter an input, the input appears as a string, or whatever is received is a string. So we have the same example that we used at first, and then this time we pass the text which will be received into the type method. Okay, so type, we open the parenthesis, and then we pass whatever we want to check its data type into this. So we run this part. It says enter a double digit value. Now bear in mind I'm entering 23. This is an integer, but then we would have a data type of a string, because like I said, input would always receive whatever input you give it, and then it will treat it as a string. And then if you want to format it, you can do the formatting from there. Right. Now we also have this. So we have 1, 2, 3 as a list. Okay, and I mean, when we move on, we will see why we call this a list. I mean, simply because of the square brackets, and there are, I mean, a whole lot of data types we'll be looking at. So if I pass this 1, 2, 3 into the type method, we would have the output list. That means this data type is a list. And bear in mind, we've done variable assignment, so think of it this way. We can also um, have this in two steps. Let's say we have the variable v, assign the value 1, 2, 3, which is the list, and then we check for the type of v, and it produces the list. And that's simply what we are trying to do here. Okay. We go back, we try same for hello world, and we see it's a string. So I mean, we can try a lot more examples, and we see how it works. Now there's something to note here. When we tried the type on 2, it produces int, but when we try type on 2.0, it produces a float. Okay, now these two are not the same, even though to us as humans we know 2 and 2.0, I mean, they look slightly the same, but there's a huge difference between them. When you are programming, these two are not the same. The number of bits they are assigned are not equal, right? And so you need to understand that in programming there's a big difference between these two data types. So if for instance I try to, let's see, this 2 equals to 2.0. Okay. Okay, so I think we'll try some extra examples on this, and so that we get to know. Now over here it's producing true, but at a point we will see why this is not the case, because I mean the data types are not the same. One is an int, one is a float. Integers are treated differently, floats are also dealt with differently. So there's a big difference between them, right? And we also need to understand that in Python there are lots of data types. Okay, so we have the numerical data types, so we have integers, floats, complex numbers. We also have dictionaries, we have booleans. By booleans we mean true and false. And we also have sets, we also have sequence type data, which are strings, tuples, lists, and it gets even way extensive beyond this. We also have tensors and the rest. So there are lots more data types we can look at. So we'll start off with the string data type. So these are data types that are kept in either a single or double quotes. So for instance, we have over here Python, which is passed in a single quote, and we can also pass that in a double quote, and that is a string. Okay, and it's also necessary that once you open with a double quote, you close with a double quote. Once you open with a single quote, you close it with a single quote. So let's try this here. So we look at the data type of this variable here, or this um, string here, and it produces str, telling us that this is a string data type. Now we do the same thing here by applying value assignment to a variable. So we assign this a string variable to the variable x, and then we find the data type of x, and that produces a string. Okay, now I remember earlier we said if I want to do a multi-line comment, we'll do, I mean, we just do that with the three single quotes opening, three single quotes closing, all right? Or the three double quotes opening, three double quotes closing. Now, in this aspect, this also works perfectly well as a string, because in this case, I want to make use of single quotes as an input. I want to make use of double quotes also as an input. And then also bear in mind that I'm using the print statement. So this will be treated in this case as a string. So I can print out this, and it gets to print exactly what we've passed in there as an input. So this will produce, this string has a single and a double quote. the way it is. All right, and that works perfectly well. Now, it's also necessary to note that um, in Python, our indexing starts from zero. Okay, in other programming languages, it's different. So others will have their indexing starting from one. In Python, the indexing starts from zero. What we mean by index is, think of it as position. All right. So if I have a string of this form, let's say we have the string Python, or okay, let's use one quantum Ghana. So there's a string one quantum Ghana. It means the first uppercase O has a position of 0. The next one has a position of 1, and it goes in that order till we have n minus 1. Okay, so it always starts from 0 as the first ID, and if you want the fifth item, that will be ID 4 or the index 4. So let's say we have this assigned to A, and I want to produce just the uppercase O. Now I need to subset this. And since I know that O is at the position 0, I just run A into square bracket 0, and that would produce my O. Okay, and that's it. If I want a range of items, say the whole of one quantum, this starts from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, now to indicate a particular range, we would use the colon. So from 0 to 9, we are thinking of it this way, that it should produce, okay, the first 9 elements. But in actual sense, this wouldn't produce exactly what we want, because when it comes to the range method, always the final point, okay? So the first one is the initial, this is the final. Always the final has to be one place above the particular range you're working with, okay? Because it doesn't treat the final step as part of it. I mean, the final index as part of it. It deals with that exclusively. So if I want the first 10 elements, then it means this should be 0 to 10 to produce one quantum. Okay, that's because this 0, position 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, that's the first 10 elements. But if I should pass in here 9, that would produce just one quantum without m. Okay, so I need to go a step over my final point I'm subsetting to, and then I can have all the items I want to subset. Okay, so we have a couple more. So the variable we defined here, that's the x. We still have some examples to try with it. So if we have, say, x at position 0, it produces a. Okay, let me reprint the x here. So let's say we have x so that we know exactly what x is. So we have a string variable. Now x0 would produce the uppercase A, which is the first item, x2 colon, and then there's no final point. Now think of it this way. If I don't indicate the initial, it will pick the very first position. If I don't indicate the final item, it would pick the very last position. So if I start from 2 to nothing, it means 2 all the way to the end. So this is position 0. The space here is position 1. The S is position 2, all right? Which is, I mean, index. Think of them as index. So those are index 0, index 1, index 2. But there's the first place, the second place, the third place, all right? So from 2, it means we are starting from the third point, which is the second index, all the way to the end. And this will produce just string variable, right? And then we also have, in this case, I do not specify the starting index. I also do not specify the ending index, but then I give a step, right? So we can use the step. Now, if you don't specify the step, it means it uses a default of 1. So it's just going to start from whatever you are, I mean, your starting point is, and be increasing in steps of 1, all right? Now, in this case, I want to increase them in steps of 2. So it should start from the very beginning, go all the way to the end, and then, I mean, pick the items which are at positions in steps of 2 from the very first one. So if I run this, I would have, bear in mind, our x was, I mean, this was our x. So if I pick this one, it skips the next one, goes to s, skips, goes to R, skips to N, skips to the space, in that order. So by running this, we would have just those items which are the even indexes being produced. Okay. Now, if I want to do same for say the odd one, I know, I mean, I can start at say 1, and then I still have my steps of 2, right? And that's going to start from position 1 to, I mean, index 1 to index 3 to index 5 to index 7, in that order. Okay. And that's how we do string subsetting. Now, with strings, you can also look at the length of the string. So some of these things seem very basic, but then they come in very handy even at the advanced level of programming. You would still realize that you have to go back and get the basics. So let's say we have this x, which is our string, and want to see how many items we have in this string variable. So we find the length of x, and it tells us, okay, we have 17 elements within this string. Now space is inclusive, so we have a, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. That's exactly 17 individual elements contained within the string. Now, think of this other part as, okay, I did a subsetting of x. I selected just the first element, which is the x0, and then I found the length of that first element alone. And so that will be just the length of a, and that produces 1. Okay. Now, what we did for the even component, we want to find the length of all the items that are located at the even index or the even indices. And so by finding the length, we notice that we have 9 elements which are positioned at the even indices. All right. And we can, you can try your hands on more examples as, you deem fit. Also, we can have string concatenation, that's merging of strings. Okay, so Francis, I think you have an issue, right? So Francis, if you have any challenge, just move to the top right of the class, and then JC will be there, and so you can move to the top right of the class, and JC will be there to assist you, or you go to the bottom part of the class and you meet Patrick in one of the help rooms. Okay, and then, like I also indicated earlier, whatever we are doing here is accessible on the GitHub page. So when you go to the GitHub page, you have the data, the images, the the various scripts, the notebooks we'll be using. Okay, so you can just go there and then get them. All right. Now with string concatenation, it means we are merging the strings. So let's say I have the string hello, and then I have the string world, and I want to merge them. So I just use the plus symbol. Okay, so this works because I'm dealing with two strings. So if I decide to add two strings, it means I'm concatenating them, and this will produce just one string, which is hello world. Okay, so let's look at this other example. We have one, which is assigned to the variable a, and then we have quantum assigned to the variable b, and we have Ghana assigned to the variable c. So over here we have print a plus b plus c, and this should produce one quantum Ghana. Okay, bear in mind there's a space here because the quantum has a space at the end. All right, so we'll have this produced as one quantum Ghana, and that's how string concatenations are done. So you can try your hands on some other examples. If you have any challenge, just let us know and we can assist you. And
Yeah,
also we can,
hello.
yes, please.
This when you get to there where where you are supposed to go when you need help, how would you interact with those who are there?
Yes, so once you get to the desk, they are in that particular room, so you can start talking to them, and it wouldn't affect any of the, I mean, the sessions going on in the class.
Okay, thank you very much.
Right, you're welcome. All right, so for the string repetitions, let's say I want to produce the string a certain number of times. So I have the string, and then I use the multiplier to indicate the fact that I want to repeat that string. And then we have an integer indicating the number of times I want to repeat this. So let's say I want to produce hello 3 times. So I have here hello times 3, and it produces hello, hello, hello. All right. So let's say we want to try that on, say, Python, and we want to try this 30 times. Okay, so we have Python printed 30 times, or yeah, being repeated 30 times. And that's how you do string repetition. So we also have another example down here which you can try your hand at. Okay. Okay, so I don't know if there's any question. If there's any question, we can address it now. So Adam, please, if you have a question, come to the spotlight. Okay, so you see where the mic, I mean the megaphone is in front. You can click on that, come to that point, and then ask your question. Right. All right. Okay, so I think we are good to go. We can still go on. All right. So when we talk of string escapes, we are looking at, I mean, some, they are just simple tweaks you can use to sort of add some formatting, and then also some, um, some other skips also to your strings. So let's say I'm producing an output and then I want it to be moved to the new line. So um, let's say in this case, I want the Python to be produced on individual lines. So I can pass in here within the string, because these are string escapes. So within the string, I can have a backslash n. That means produce a new line. So, and this is repeated 30 times. So print Python, produce a new line, and then print Python again. So it means you print the Python, you go to the next line and print the Python. So it wouldn't be produced as, all joined together on this one line, but rather it will be produced this way, where we have Python, then the next line Python, 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 in that order, 30 times. Okay, so you can give it a try also. Okay, so we have a whole lot of string escapes. Now, since we said the backslash becomes the start of the string escape, what if I want to type a string and this time I want to print a backslash in the string? Now, the way you do that is to have a double backslash, so that then it knows that, okay, we are not using the backslash to attach to something as a string escape, but rather to sort of produce the backslash itself. All right. And also bear in mind that we said single quotes. Okay, for instance, I'm dealing with strings. I'll pass a string into a single quote or into a double quote. But what if I'm typing something as this? So let's say um, I want to produce this in here, say Kofi's pen, right? Now this will produce an error, because even though in my mind I'm thinking of producing Kofi's pen, but this single quote closes the very first one. So this whole s to the pen is not understood. It thinks of it as a variable that hasn't been assigned a value, or a whole lot of confusion in there. So this will produce an error. All right. But then if I want to produce this single quote here as exactly, an inverted comma, then I'll need the backslash before that. And this will produce the output Kofi's pen, exactly the way we want it. All right. So let's say I also want to, just pass in here, say Kwame said, let me use the double quote so that will be more easy to explain. Yeah. So let's say I have this. Kwame said, my name is Kwame. Right. Now you look at this. What we're trying to say is that, okay, Kwame actually introduced himself by saying my name is Kwame. So this double quote has closed the double quote in the beginning part, and this I mean these ones are not understood. So if we want it to work as a string, then it means we want this quote and this other quote to be on the information that Kwame gave, which is my name is Kwame, because that's a quotation. We are quoting Kwame, so we can then pass in here the backslash on this, and then the backslash on this one, and that will produce exactly Kwame said my name is Kwame. Right. So think of string escapes like that. And we also have, the backslash a. Backslash a wouldn't work on the Jupyter notebook. At least I've tried that for a while and I know it doesn't work here, but it works on the spider interface and then a couple of other interfaces. Now with this, what you are doing is just to ring the bell. So if you know what that tone is, let's say you are installing something, then you receive an error message, the tone that comes with it, this will produce it. So this can come in very useful when you start building huge sets of code, and then at a point when the code is executed, you want to prompt the user. You can just pass this in there. And then if you also want a backspace, maybe you want to go back one space, use a backslash b, a new line backslash n, a tab, that's horizontal tab, backslash t. So let's say we want to, so we have some other examples here. So like we saw in the very first part, the new line, and also the same thing here, and with the tabs. Yeah, so let's see the tabs. You have the backslash t here, and we can see the spaces in them are not single spaces, these are tabs actually. All right, so that's it. It comes in very handy. The string escapes, you can always make use of them. All right, now as strings also have some other formats you can apply to them, so they are actually applicable. So for instance, I have this Accra, which is the string. I can change this to uppercase by just adding at the end of the string dot upper. And bear in mind, there's a method, so the upper method is not one of the exceptions. So it comes with open and close brackets. So I would pass here Accra dot upper, open and close brackets, and this will change it to uppercase. All right. And in the next one, we have our string, which is intensity produces short-term results, consistency yields long-term results. And this string, we are trying to change it all to lowercase. So at the end of the string, we pass in here dot lower. And bear in mind, lower is also a method, so we open and close the brackets, and this will change the whole uppercase text here to lowercase. And we can also change them into a normal sentence case by using the dot capitalize method. And this would only make, once it's a complete sentence, it will just make the first word, the first letter of the complete sentence uppercase, and the rest will just be lowercase as a normal sentence case. And we can also split, we can split the string. So let's say we have this string, which is x. Now I want to split the string along where there are spaces. So my string, which is assigned to the variable x, I call the x and I add a dot split, and then I pass in here what I want to use as a splitting, or the splitter. So in here I had my space being the splitter. So wherever there's a space, it will be broken down from there, and then this will be produced, this will produce a list with all the individual separations as individual items of the list. So let's say we want to split along the part where we have uppercase s. So we run this, and then our splitter is the uppercase s. So wherever there's s, it breaks it up, and then they become individual items of a list. Okay, and that's it. So there are a lot more we can actually try out. So some other examples. So we can also nest some of the functions. So for instance, I want to split along where it's ty. Now, but bear in mind, if I just split along the ty, there's no ty in lowercase, so it doesn't produce any split. But then I can change the ty to uppercase because the ty here is a string. Okay, so I have this ty. Let me space them this way so it becomes easy to identify. So we have the x.split method, and we are splitting along the ty, and the ty, we want to first change the ty into uppercase so that it knows that, okay, I'm going to use an upper ty to be the split, and then we pass that. So wherever there's a ty, it's split, and then we have individual items. So all these are individual string items within the list, and that's what we have there. All right. And like I said, we can also nest some of the functions. So after splitting, we can find the length of it to give us the number of items in there. So we found the length of this, and it tells us we have two items in the list. For instance, when we look at this, we have the first one being the intensity, and then the other one being what came after the ty in uppercase. All right, so just two items. So you can nest a couple of them. And okay, there are some other things would, I mean, you can always find useful when you go through the notebook. For time's sake, we won't be looking at all of these ones. Okay, so we can also do a query replace. Let's say I want to replace the word hello with hi in the string. So we have the string here. So our string, which is a variable x, is hello, hello all, welcome to OneQuantum Ghana. And I want to replace the hello with the hi. So once I pass this replace statement to the string, and I tell it to replace the first item here, which is hello, with hi, it changes the hello in the string to a hi, and that's what we have. Okay, bear in mind they are new lines because of the string escape we use with the backslash n. So if I take those ones out, I expect it to be like this. So hello changes to hi, hi all. And you can also do a search within the string. So you can find, for instance, the first position where you have a certain item. So let's say in this, we want the first index where we have the character or the letter E. So if I run this x.find E, it tells me, um, so it tells me we have the E at the point or the index 1. Now when we go back to our x, we have hello, all right? The x unreplaced is the hello. So we have H being the first index, okay, which is the index 0, and then E is at index 1. So this produced 1, telling us that the first time it identified E was at the index 1. And then also if we do the R find is more like a reverse find or doing the right find. Now this goes in the reverse and finds the very last position of the variable E. And so this tells us that this at position or index 23 within the string X. Okay. And there are a whole lot more formatting we can do. Now, this other aspect, I mean, when I'm dealing with um, some string outputs, you can just pass them this way using, for instance, we make use of the curly brackets as a means of formatting the item we are producing within the string. So, for instance, in this case, we have welcome to the year the program organized by this organizers. Okay, now this is our string, but we are passing input into this string. For instance, we want to pass the variable year into the string. All right, and so we pass that year into the curly brackets. So if the year in this case was say 2015, it would replace the year over here as a, I mean, we use the value for the variable year. Okay, and then whatever value was assigned prog would be replaced. So the same way we'll have, let's say, the program name, whatever value was assigned to it will replace the variable here. The same for the organizers. Now in this case, at the end of this, I decide to format. Okay, so the default syntax is we have our string this way, we have our string, and then at the end of the string we have dot format, and then whatever we pass into the curly brackets we would have to format that here. All right, and that's the string, I mean the syntax. So in this case we are formatting, for instance, we pass in here the year, which is 2022. We have the organizers being OneQuantum Ghana. We have the prog being Python programming. Okay, so now if I produce this and then I print out the first, it would, instead of having the year as a string the way it was, it would replace the year with the value we gave to the variable, which is the 2022. Right, replace the prog with the value we gave to the prog, which is Python programming, and then replace organizers by the organizer value we gave. Right, and that's also another way of formatting your string outputs. Okay, now the good part of this one is that you can also, I can arrange it in different forms. So I can decide to start with the program followed by the year. Okay, and it will still work well in this case because bear in mind I've done an explicit assignment of, okay, what the program is, what the organizers are, what the year is. All right, so irrespective of how I replace it, it still would work because it has been defined. Now the other option is using the index. Now within this formatting we have these items, and again, like we said, indexing starts from 0. So index 0 is in this case Jeffrey, index 1 is 174. So we have, for instance, my name is and then we pass in our format. And this time we are not using any variable that's assigned a value, but rather we are passing in here the index. We are saying that go into this formatting, pick the first item you see, and then pass that into this place. All right. So we would have this change as my name is Jeffrey, and then the formatting here would replace the value we have into that string. So I'm 174 centimeters tall. Okay. Bear in mind if I reverse this, okay, it's going to have a reversed format. And if I pass in an index that is non-existent, say index 2, it will produce an error because there's no item at index 2. There's just index 0, index 1. All right. And that's it. And you can also just use blank, curly brackets. For instance, we have this open curly bracket, but we don't pass anything. We don't pass the index, we don't pass the variable into it. Now, what that means is that it should use a default assignment. So the first curly bracket will be for the first index by default. The second will go in for the second. And if they are multiples, they will be positioning themselves like that in that order. So for instance, we run this and then we have Ghana replacing the first curly bracket and then 6 replacing the second one. So this produces, say, Ghana attained its independence on 6th March 1957, right? And that's as simple as that. There are some trial examples here to see whether you are conversant with it. But like I said, the notebooks have been shared and we also have limited time. So since you have the notebooks, you can try your hands on them and then hopefully, like we indicated yesterday, the Gather portal will still be available. If you have any questions, you can come on and then ask. And we also hope that tomorrow, before the session, will be available, and then um, those who have tried their hands on it can, discuss with us whatever challenges they had, and then we see how best to assist them. So, I mean, you can try hands on some of the examples. Now, that's a lot to do with the strings. Now, when it comes to numbers, we have, I mean, different types. So we have, yes, any question,
Yeah,
please?
hello.
Yes, please.
Please, I also know of another formatting of a string whereby maybe they use F before they bring the quotes and they will type in whatever they want to do. So I want to know the difference between that type of formatting and what you just taught.
It's virtually the same thing. They work similar. So it's just about finding one and then adapting to it. So there's no difference. It works the same way. Um, I think maybe I'll just indicate some extra examples. I mean, even in this case, for instance, in as much as we have this string, I can still pass in the format for the particular string directly into this, and then maybe instead of 6 showing as 6, it will just show us maybe real number. I mean, as a float or something else and all that. I mean, yeah. So there's no.
And which one is I mean good to use now? I mean current age, like the one you if you're working, it's advisable for you to use.
Okay, so I mean, it's this. So one of the things we need to understand when it comes to programming is what you find comfortable to use is what I would advise you to use. All right, unless of course you do a time run, okay, on your code and notice one is quite slow, so you want to go in with one that maybe works faster, maybe for optimization purposes. I believe maybe if there's
No,
some
okay.
time on the final, they will look at how to refactor codes, for instance. So I mean, somebody can run over a million lines of code and say, okay, my code is very slow, but that same code can be split into, very simple lines. And so it comes down to what you would find very helpful to use and what would be more optimized to use. Yeah.
Okay, okay, thank you very
All
much.
right, sure. You're welcome. All right. So I don't know if there's any other question, so we can address that before we even move on. Okay. So yes, I'll do that. Let me quickly share the link to the GitHub page with you all. Okay. All right. So when you go there, you can also go through the README and then see. I mean, you can. There's a Git procedure to just download the information if you are not conversant with Git. I mean, that one line will be quite useful and it would help you. Okay, right. Okay, so I think we can go on with the numbers too. So with numbers, we have integers, we have floating points, which is the decimals, and then we also have complex numbers, right? Um, we have just a little over 40 minutes, so we'll try to move a little bit faster, but still make sure we understand. So for instance, I find the type of this element, okay? So I print the type of the 0 point. This produces a float because 0 point, because of this decimal point, that's a float, all right? And that's different from just zero. Zero is an integer, okay? And so integers are numbers without the decimal points. The floats are the numbers with the decimal points. And in other programming languages, there are various bits that are allowed for particular, I mean, floating point types. But in Python, I mean, it's quite unlimited. So, I mean, you can pass in anything. Depends on the, I mean, memory capacity of your PC, and then also, I mean, the PC's own assignment of integers. I mean, of floats. That's it. The bit representations. Yeah. And then also with complex numbers, I mean, we have the i's or the j's. I mean, that's it. So in Python, we can also do same. Now there's the real part. The real part is the first one, and then the imaginary part is the one with a j. So for instance, we have 4 plus 2j. We find the type of this, and this produces a complex because it's a complex number. Now we can also produce a complex. You see, unlike this first approach where we just typed in the real plus the I mean the imaginary part, we can also use the complex method to produce this complex number. So we have complex on 2, 3, and this produces the real part and then the imaginary part being 2 plus 3j. Alright, and that's it. And this is just a simple question for discussion, but for time's sake, we'll skip trying to look at the difference between 2 and 2.0. And then, just as for numbers, as we deal with numbers in our day-to-day activities, we can also apply some basic arithmetic to our numbers. We can do additions, subtractions, multiplications, divisions. All right, bear in mind, on the PC you don't have the division as the division symbol, the line with the dots above and then below. So we use the forward slash. That is a division symbol, and that's what is um, visible on your PC. So you need to also take note. And for multiplication, we use the star or the asterisk. The subtraction is the normal um, minus symbol. Addition, the normal plus sign. And we also have the modulus. Now, if you want the remainder, it means we make use of the percentage sign. And this will give us the remainder after the division. And for exponentiation, that's raising to a power, we use the double asterisk or the double star. And for a floor division, that's if I want to get the integer part of my division alone, all right, then I use a double forward slash. So we can try the addition just by adding 2 to 3.2 and it produces 5.2. We can do the same for multiplication, the subtraction, division, and then now you notice that in this division, when we did 4 divided by 3, we had 1 point, all the you know decimals thereafter it. But when we do the floor division, in this case, say 4.1 divided by 2.1, this produces just the integer component. All the decimals are taken off. All right. Now, the same way, if we have say 4 double forward slash 3, it produces just one. Okay. And bear in mind, this is purely the format that it gave was just based on the format of the numbers we divided. But then what is produced is just the integer component. All right. And that's it. And then if we also want to produce the remainder, we use the modulo. So 5 mod 3 will produce 2. That means 3 goes into 5, 1 with a remainder of 2. So this produces a remainder of 2. Now, a combination of this floor division and then the modulus division is very, very powerful. I mean, throughout my years of using Python, I noticed that these two are very simple. I mean, it's very simple to ignore them, but when you start doing complex stuff, you realize that these two are very, very useful, especially when it comes to, you know, you are doing your subplotting, you are dealing with data at different positions and a whole lot of complex things. These two, a combination of these two makes your work very, very easy. So let's, really take note of them. And then exponentiation to raise to a power and works the same in this case. All right. Um, Maybe I wouldn't talk of this particular one for now. Yeah. And that's by way of the numerical aspect, the numbers. Okay. We also have the Boolean data type. By Boolean, we're referring to just true or false. So whatever, whenever you have a true or false statement, that's a Boolean data type. So if you find the type of, say, true, that produces bool. And bear in mind, true is case sensitive. Okay. So if I type in uppercase or true, it will produce an error because this is not how Python represents true. If I write also true in lowercase, still an error. If I decide to, do any other thing, still an error. It has to be just uppercase T, the rest lowercase. And this will produce a Boolean data type. The same for the false. Okay. Now, when we have this statement, say we are doing a comparison of 2 and 3, I'm saying that 2 is greater than 3. Now, this will produce a false statement. This will produce false. So, if I find the type of the output, the type will be a Boolean. Okay, so let's try this. Let's just say 2 greater than 3. That will produce false. Okay, and now I'm saying what's the type of that false statement? And type of false is a Boolean. So, that's a data type of a Boolean. All right, and that's simply what we mean by Boolean. True and false statements. Okay. If you still have any question, you can type them in the chat and then I'll read and then address them as we go on. We also have the list data types. We'll come back to list a whole lot more. Lists are just contained in square brackets. So, for instance, we have these items, and it can be a combination of any data type. So, we have 1, 2, 3, 4 passed into square brackets, and so this is a list in Python. So, if you find the data type of A, it produces list. All right, and the other data types, once it's not a square bracket, it is not a list. Okay, and we can also have list in multiple forms. So we can have, say, a1. I open the square bracket and then I'm going to place multiple of them. So within this I have a first square bracket, say 1, 2, 3, 4, and then a comma separating one square bracket from the next. Say maybe h a, say T, say P. All right, and then I find the type of A1. It's still a list. All right, but it has different, like, multiple dimensions. That's all. But we can nest lists also together. That's all this means. And then, just as we did for the string, we can also subset list. So let's take this list, which is a list of names. So we have Abel, Ima, Quantum, Legendre, and then Ghana. And we find the data type is a list. And just as we did for the string, if I find the first item, which is position 0, it produces the list at position 0, which is Abel. And I can have a range of items. So 1 is to 3 means 1 to the step before 3. So it's just producing 1 and 2. That's the second and third items. So this is Ima and then Quantum. And we can do same, producing the odd index, the even index, and a lot more. And you should also note that lists are mutable. When you say something is mutable, with our basic biology, we know mutation means ability to change, right? When we're dealing with genetics and all that, when we talk of mutation, we are talking of the ability for something to change. So it means we can change items within the list. So let's say this, the names we produced, the position 0 is Abel. All right, I want to replace Abel with something else. So I just indicate that um, from this names, the position 0, it should replace that with this string, which is new name. And then when I produce the names, we would have Abel change to the new variable we assigned. Okay, and once this doesn't produce an error, it means this is mutable. So lists are mutable. Not all data types are mutable, but we know lists are mutable. Strings are not mutable. Please, strings cannot be changed. even though we can identify the position, we can't change them. So for instance, if I have a string, say hello, all right, and position 0 of hello is H. Now if I decide to change this to say Y, to read yellow, this will produce an error because strings do not support, you know, data assignments. They do not support assignments, so they are not mutable. All right. Okay. And also, if I want to look at the reverse of the list, I want to produce a list in a reverse. We can use the same approach. The starting point we leave as blank. The ending point we can still leave as blank, and then we rather reverse the step. So instead of having a step which was a default of a positive, we will change the step to a negative. And so this means that from the first position, go back one step. So since our list is in this form, it's going to go the reverse. So this was supposed to be the first position, but then it doesn't produce that. It goes a step back and then moves on and on and on till the end. Okay, and that's what we are having. And so we can also do same dealing with, I mean, a bigger separation, this time in steps of two, but in the reverse. And that's what we have. And we can also append to a list. That means we can add new entries or new items to a list. So the names we had, we can add a new string to it. So let's say we are adding the name Michael to our names. So we have names.append, and then we pass in whatever variable we want to pass in. Not just string, you can pass in anything, say integer, float, it will still work. And then we echo the output, and we see that now to the data or to the list we had, which was the names, Michael has been added. If we rerun this, it would add Michael again. So we have Michael re-added. Okay. And so just as we've added, we can also remove. So if I decide to remove, if there are multiple, we remove the last one first. So we change the append to remove, and then Michael goes off in the first case, and we have just the second Michael, I mean the exact Michael we added at first left. Okay. And also we can, apply all these built-in list methods. So for instance, finding the count of a certain number of, I mean a certain entry within. So let's say we want to see the number of times the name Ima appears, depends on how you call it, whether Ima or Ima. So want to see the number of times this appears in the list names. So we have the list dot count, and we pass the entry, say Ima, and it tells us Ima appears just once. Now if I append Ima again and I do a recount, this time I should have two of that, because the names will then have the Ima re-added. Okay. And then also we can find the index of any item. Okay, so there are lots more we can do with the lists. I mean, since you have the notebooks, it will be easy to try your hands on this. All right, so I'm going to move, because of our time, onto, I'll just move on to tuples. So when we talk of tuples too, they're also another form of data type, and then these are, unlike the list came in square brackets, tuples are contained in like normal or regular brackets. Okay, so if I pass in this same 1 2 3 4 5 into just regular brackets, and I find the type of A, it tells me there's a tuple. Right, the same way as the list, we can also do subsetting of tuples. We can, I mean, subset by range, but tuples are not mutable. We cannot change tuples. So we have here a sort of Python standard data, hierarchy, telling us which ones are mutable, which ones are not mutable. So for instance, over here, we see that strings are not mutable, tuples are not mutable, bytes are not mutable, but lists and then byte arrays, which we'll deal with arrays later, they are mutable. All right. So if I try for this A, that's the tuple we created over here, which is the 1 2 3 4 5. If I try to replace the first element with a new item, say 3, this produces an error because tuples cannot be changed. All right, you can't reassign a new value to a tuple, and like I said, it's the same for strings. So yeah, and just as we did for lists, we can find some other built-in functions, the count, the index of certain items, and then move on. And we also have the sets data type. Now think of this as just ordinary sets that we use in math. Okay, so a set of items. Now sets are contained in curly brackets, And for sets, we don't have duplicates. Okay, if you are creating a set, there won't be a duplicate. So it will just look at individual elements. I mean, appearing just, it will just give you their individual time they appear. That's why it wouldn't give you any duplicates. So if I want to, it's very easy to use the sets also. Let's say if I have a whole data set and then I want to see the, you know, individual elements within them, okay, without repetitions, I just would make use of the set and it will just tell me, okay, we have this item without the repetitions. So let's say we have this A, 1, 2, 3 contained in the curly brackets. Once we find the type, it tells us this is a set, right? Also, we need to understand that a set is unordered. It cannot be changed. I mean, there's an asterisk, so it means you can change it through a different medium, but then we can't just do a direct sort of change like that, like, okay, based on position, just change. No. And then also, it's unindexed, so it cannot be, I mean, indexed. So if I find the type of A, we have a set. For instance, we have the set 1, 2, 3, and then 1 and high. Now, 1 is repeated twice, but when we produce A1, we'll see that 1 just shows 1 just one time because sets do not allow duplicates. And then also they are on index. So if we try to find the position 0, it says no, you can't. I mean, it's unscriptable, so we can't find the position based on that approach. We can also assign, I mean, reassign a value to it, so it can be muted. But if we want to add, there are different ways. You can have the set.add and add a new entry. So a1.add, maybe add the word new, and we will type a1 now. We've added. So that's why we said it can be changed with a star, but it can't. I mean, the star means we can have a different way of changing, which is unique to sets, but we can't just change it by this approach. Okay. So we can add a new item. We can update. Also, by update it means we can just replace what's the name? So we are adding the item in no particular order. We are just adding all these items to it in no definite order. And also we have what we call frozen sets. So these are subsets of sets, but these ones, as the name implies, they are frozen. It means you can't even change them. All right. So we create that by using the word frozen set, which is the method frozen set. So I have this list of strings, which is 1, 2, 3, and then I pass them in here. I think this will always be easy to understand it this way. Okay, so we have the list 1, 2, 3, and we've passed it into the method frozen set. So this will produce a frozen set of x. And when we check what the x is, this is how it is. So it's a set, but it's frozen, so it cannot be changed. Yep. So can you use append? Okay, so let's give it a try. I mean, programming is always, best to try it out. So let's say we have a1 dot. Let me check if the a1 is already loaded. Okay, so we have a1 dot append, and then we try appending, say the letter p. Okay, so it says set object has no attribute append. Okay, and so Francis, I believe your question is answered. Okay, so that's it by frozen sets. We can also have some other attributes of frozen sets, and we also have what we call dictionaries. So this works just the way you think of, the normal English dictionary. So when you go into your dictionary, you go find a word, and then you have the meaning of the word, or sort of the attributes of that word. Think of it that same way. So with a dictionary, we have a key and a value pair. So we have the key, and then it's assigned a value. Now, in this case, we have this dictionary A, and just as I mean we said for sets, dictionaries also go with the curly brackets. So we have the curly brackets, and then the first item, we have the key name. All right. So the key is name, and then the name has been assigned this name, which is the value of OneQuantum Ghana, and then the country has been assigned the value of Ghana. The course has been assigned the value of Introduction to Python, and then the year has been assigned this. Now this is a dictionary data type. So if we find the type of A, it produces dict, right? And if I want to find, let's say, what is contained in the year, just as if I go into a dictionary, I'll find this word, say maybe year. What does year mean? I can just access that um, key and then know what the value is, right? And that's how dictionaries also work. And we can also use the get approach or the get method to get a particular key. So a dot get on name would produce what the name is, right? Or we can just try a into square bracket name, and that will produce the same thing, right? And there are some other, built-in functions we can use, like the items, the keys, the values, to produce one, which items are contained in there, what are the keys, and then what are the values assigned to these keys. And we have all these ones. Okay. So if there's any question, I'll address it now. Do you have any questions from the house before we move on to the very final phases of today's lesson? Yes, so Kojo, your question, yes. So this is actually true because you are saying 8 is not equal to 7. So let's see this. All right. So we'll be looking at the logical comparisons again when we get to the conditions. I mean, where we are moving to. So for instance, I have 8 not equal to 7. Of course, 8 is not equal to 7. All right. So this will produce true. So that means it's telling you, okay, this is true, that 8 is not equal to 7. But then if I rather say that 8 is equal to 7, this will produce false because 8 is not equal to 7. And exactly, it's the same thing. So 7 is also not equal to 8. So if I have 7 not equal to 8, this will produce exactly true. That is telling you that truly 7 is not equal to 8. But if I try to say that 7 is equal to 8, then this will produce a false statement. I don't know if you are okay with it. All right. And that's what it means. Okay. So any other questions before we move on? So if there are any question, you can, I mean, if there's any question, you can ask. Or if you think it's quite specific, you can also meet the assistants in the various rooms. Okay. And if you have a question that's open to the class, you can come to the spotlight and then ask it so that we can all benefit from it. Okay. All right. So let's move on to the conditions. So when we talk of conditions, I mean, we all did conditional statements in, English. So whenever we're dealing with if statement, yes. So Kojo, I mean, everything has been shared on the GitHub page. Um, I already shared the link here. So when you get to the GitHub page, you should be able to find the materials, and we would actually be updating them. Um, so I think even in subsequent days, you still have to check back. And yeah, see. All right, thank you. All right, so when we talk of the conditional statements, think of it as, basic English. We are dealing with conditions. So if this happens, then I should do this. Or if this doesn't happen, then I will do that. All right. That's how conditions work. And it's the same with programming. So it's a language, but we only have to speak it in the language that the system would understand. All right. So we have some comparisons we can do. So for instance, the double equal sign. Bear in mind that when we said we're doing variable assignments we use single equal sign. Okay, so if I use a single equal sign, it means I'm assigning a value to a variable. But the moment I use a double equal sign, it means I'm doing a comparison. I'm comparing one item to the other. So if I want to do a comparison, then I have to use a double equal sign. And then if it's not equal to, use the exclamation and then the equal sign. That means not equal to. And then we know our greater than and our less than symbols, which are, I mean, quite easy to understand. And then we have greater than or equal to. So unlike the normal English symbol, which will have the greater or the equal under it, we can't have that symbol on our PC. So the best or the closest we come to is using a greater than followed by the equal sign. I mean, the reverse is not the same. If I have equal followed by greater than, it's not a greater than symbol. All right, it's not greater or equal to. That's a different thing. And then also, if you want the less than or equal to, it means the less than followed by the equal to. All right, and then we have some examples here which we'll be trying more our hands on. And we also have the logical operators. The logical operators, I mean, when I want to now bring on board a combination of, comparisons. So, for instance, we have the logical and, the logical or, the logical not, right? The and statement, that means, okay, we are trying to be specific that, okay, both statements should be true before the result is true. So, for instance, we have this double ampersand indicating the logical and, or you can also use just the word and. Now, this means that the two statements should be true before the result is true. So, in this case, for instance, we have 5 less than 2 and 5 greater than 3. We all know that 5 is definitely greater than 3, so that is true. But then 5 is not less than 2. So, this will produce a false output. So, this would only be true if both statements are true. Right, and then we have the logical or, which you can use just the two, I mean, vertical bars to represent or use the word or. Now this works if, or this is true if even any one of them is true, right? If any one of them is true, it produces true. So we have 5 less than 2, 5 greater than 3. 5 is not less than 2, so this is false, but 5 is greater than 3. And so once we have even one true statement, the result is true. All right, and then the logical not is, we are trying to say that this should be true if the condition is not exactly met. All right, so we are having this 5 less than 2 is false. Okay, 5 is definitely not less than 2, but we are saying that not 5 less than 2, so we are trying to say that the output here, we are saying it's not false. All right, and so this will only work when the output is true. So once we said 5 less than 2, that is false, so it produces a false, but we are saying not false, so the output is true, and so we would have a result of true. And this is some breakdown on how the logical and, the logical not, and the logical or works, right? So you can take time, go through them. And then we also have a broader case use at, that's where we now do some, real-time decisioning. So for instance, let's look at this example. We are going to combine a number of items that we've done. So the first part, we have the variable assignment. We assign the value 5 to the variable x. And then by syntax, when I want to make use of the if statement, so think of it this way. It is the if, all right, let me make this a markdown. So our syntax is, we have if, and then we pass in here the condition. And then right after the condition, there should be a colon. All right, the colon makes us understand that this is a whole construct, this is a whole structure. All right, without the colon, that produces an error. And then when we enter the colon, anything that comes after the colon should be indented if it is part of that construct. All right, so if this is a part of the construct, it has to be indented. That means it should be tapped. All right, and then we have the actions to be executed. All right, so the action, if condition is true, so this would be, or if condition is met, let me use that instead. So the action here will be produced if this condition is met, and that's how the and that's how the just a minute. Okay, and that's how this works. So we have the if statement, the condition, and then after that, the come on, just a minute, please. Okay, let me just leave this part where it is. Okay, so this is how this works. So we have the if statement, which is a keyword that has to show, followed by the condition. So the criteria comes, then after the criteria, the colon, and then we have the action to be executed if the condition is met. But that should be indented. Okay. All right. So we have this example. So we have x being equal to 5. Okay. And we are saying that if this condition is true, that means if the condition is met. So if x is equal to 5, Now there's a comparison, so it's a relation. So we are going to have a double equal sign, not a single. If I pass in a single equal sign, this would produce an error. Okay, it tells us syntax error. And you see this mapping onto the equal sign, meaning this is not right. We need to do it right. Okay, and then at the end of that, we have the colon. And then, you know, by default, because we are using the Jupyter interface, when you get to the edge of right after the colon, if I hit enter, it tabs by default because there's an interactive environment or an interactive IDE. But if I'm using a text, a normal, like a notepad to program, or any of the other, very basic or hardcore um, environments or interfaces, then it means I have to be specific and give the indentation myself. All right. And all we are saying is that the action to be executed is I want to print that x equals to 5. So this will be produced if this condition is true. If our x is equal to 5. Now we said x is 5. So if 5 is equal to 5, then it means this is true. So we expect an output. Now if we should change this to say 5.1 and we compare, this will produce no output because we are only saying that this output should be produced if the statement is true. But we didn't tell it what to do when the statement is not true. So this will only work if the statement is true. So that's why when it's true, we have an output. And the same as this, if x is greater than 4, then it should print x is greater than 4, so we have an output. Now, there's also another example, less or equal to and not equal to. Some more examples you can try your hand on. Now, so this is by way of just a simple, one-way decision. Now, what if we are doing multiple decision or two-way decision? If or the alternative. So, like we said, if this is not true, what do we do when it is false? So we can then make use of the else statement. So before we come to this example, let's look at this. So let's say if 5 is greater than 3, okay, then we should print out something. So print this is true. Okay. Now, else is, even though it's part of this whole construct, but it's also another start of a keyword. Now, if you indent this here, this wouldn't work exactly the way you want it to, right? You want this to be the alternative condition if this whole statement is not true. So we then have to make sure that the else is in line with the if statement that we are giving this as an alternative to. All right. And then also right after the else, you notice that the else doesn't have a condition. Else means any other condition left. Okay, so if this is not true, all the alternative conditions that there can exist, there can be or can exist on this earth, should produce the output or the action we are going to give. So now we are printing that this is false. Okay, so if we print this, we expect to have this is true because 5 is definitely greater than 3. If we change this to say 13, 5 is not greater than 13, so we have this is false. Okay, and that's how the two-way comparisons work. Now if we want to do a multiple comparison or multiple decision, then it means we can make use of the L if, or what we call the else if. So I can say if this works, do this, else if this works, do this, else if this works, or then after all the conditions I exhausted, then I can then come in with the else, which is the final condition. So let's say we have this criteria. I'm saying if the length of hello, okay, I want us to apply most of the things we've done. So if the length of hello is greater than 5, so let's print out hello is more than 5 letters. All right. Now, if this condition is true, this will be executed. But if this is not true, what's the alternative? We are saying elif, which is like else if. Okay, but we use elif. Elif, um, let's try. Let's say hello dot starts with, okay, H. We want to see if it's true that hello starts with a capital H. All right. So elif hello that starts with H. then we should print hello starts with uppercase H. Alright, if all these two conditions are not true, then the alternative, which is else we print all these are invalid. Okay, so we run this and we have the first part was false because the length of hello is exactly 5, but we are saying it's greater than 5. So this is false. So this part is not produced. Okay, so it comes to the first alternative. Now it compares. Okay, does hello really start with the uppercase H? And that is true. So since this is true, this will be executed. All right. But if this were to be false, let's say we have here lowercase h. We are trying to say that the hello we have starts with lowercase h. Now this would be skipped because the hello we are having starts with an uppercase, so it doesn't start with lowercase. So this statement is also executed to a false. All right. And since these two are false, it goes to the alternative, the very final alternative, which is all these are invalid. But let's say we have this being equal to 5. So the very first time that this is met, okay, let's say all the statements, the first two statements are true. But once we have the very first time it's met or the condition satisfied, it means the first action is executed and then we break out of that decision. All right. And that's all. Okay. So we have this example here, which you can also try a hand on. You can enter, it says it receives an input of a name. So let's say I enter the name Quantum, or let's say OneQuantum, Ghana. Now it compares this to the name John. So if the name is John, then it should just print out, "You are welcome, John." If not, it should print out, "I don't know you, please." And we have here, "I don't know you, please." And then it will print out two decision execution complete. Next is multiple decision, and then we move on to multiple decision, which we've already seen. And so with the same explanation on multiple, where we have the if, the else if, I mean multiples of that, and then followed by the very final alternative, which is the else. You can also try a hands on this at your spare time, and then if you have any issue, let's know tomorrow. Okay. And we also can nest the statements, the if statements together. So I have multiple ifs, I can merge them. So we have, for instance, in this case, this if statement to produce this output. But within the same if statement, we are saying that if this is true, whilst it's producing this, it should still compare this other one, right? Now you notice that if I had this if indented this way, then it means it's not part of this construct. But because it's not on the same line, they are not starting on the same line, but rather it's indented under this, just as this part. It means this is also a construct within the first construct of if. All right. So it means if we have this first comparison done, once this is met, it would move on to the next one because this is still a sub of it because of the indentation. It will compare if this is also true. If this is true, if this is true, then it would move on to the very final one and produce that also. So let's say we have grade of 100. First, it compares the grade of 100 to 60. 100 is greater than 60, so it produces definitely the student scored a passing grade. Now, since that is met, it moves on to the second one, which is to compare the grade. Is the grade greater? Is the grade greater or equal to 90? Now, since the grade is greater or equal to 90, indicates that the student definitely passed with an A. And the grade is also greater than 96, so it means the person scored more than, I mean, the pass mark for an A plus, right? And that's how we deal with nested if statements. And we can do a combination of if, nested if, elif, and else, and all that together. Okay, this only comes in. It becomes more. I mean, you get better at it when you try, you know, more examples. You try your hands on a lot more, and then you get conversant with it. And the very final thing we'll look at is also the one-liner type of condition. Okay. Now, I was talking about, I think Adams asked a question when we're dealing with the string format. All right. And I made mention on some code refactoring we'll be using. Now, if I decide to write an if statement and it's, a whole long list. Each line is sort of um, processed separately. All right, it's more of registered. It's, I mean, the PC uses its own registers to sort of process them. All right, separately, and or in a case of where it's being batched sort of together, it still would have individual registers for them and batch them together and then run. So definitely memory usage would be um, a bit high if we start doing more advanced logical comparisons and the rest. So one of the things you can do for code refactoring of decision making is to use the one liner conditions, and the method is we have the action to be executed. Now, bear in mind, when we're looking at the um, if statement, we said if the condition, all right, then the colon before the action to be executed when the condition is true. But then for the one liner, we go with the reverse approach. We rather will produce the action first. That will be the action when the condition is met. Then we bring the keyword, which is the if, and then we now produce the condition, which is the condition that is supposed to be met. All right. Now with one liners, you can't just do a simple if statement. You can't just do a single decision making and that's all. You have to do two-way decision or multiple. So always the else is an essential part. So you have the action for true, the if, and then the condition which is true. Then we have the else statement and then the alternative action, which is the action that will be performed if the condition is not true. So let's say in this case we have the statement yes. We want the yes to be printed, followed by the if keyword, and then the condition we are evaluating. That is 5 greater than 2. So if 5 is greater than 2, then we expect the output yes. But if 5 is not greater than 2, then it means the else statement should be executed, which is the no. And since 5 is greater than 2, this is a true statement, so we have the yes produced. All right. Now, if this were to be the reverse, say the less than. Now, this is a false statement, so this will produce no. All right. And we can build on that. Now, if I want to do multiple conditioning in a one-liner form, then it means what I'll be generating as the elif. Okay. So let's say we have this the statement true. Let's say yes if 5 is great. Let's use the less than. Yes if 5 is less than 2. Else produce a certain output. Okay. So let's say no. Now I want to make use of elif. Right. The elif is understood as else if. Right. So it's an if condition within the first part of else. So what we can do is, since we can't just pass an elif directly in here, we can make use of the else if statement. So we have else, then I can do it without using the parentheses, but to make it very easy to understand, I'm going to pass another if statement into the alternative part, and that becomes the elif. So now what I'm trying to say is that let's have another condition, another criteria. So let's say produce even if 5 mod 2 equals to 0, else odd. Right. So now this whole alternative for the first else is another comparison on its own, which is another one liner. This as a standalone will be good. That means, think of it this way: if we have just this one as a standalone, if 5 is divisible by 2, then it means it's an even number, else it produces odd. So since this produces a remainder greater than 0, it means this is an odd number. So this as a standalone, this is a good condition or decisioning making on its own. But we are passing this into the alternative part. Okay. So like I said, we can decide not to bring the parentheses. That's if only we understand what we are doing. Okay. But we brought the parentheses just to make it visible enough. So we are saying that produce yes if this condition is true, else produce this if this is the first condition, I mean the alternative condition for the first time that is met. Other than that, the very final one, else, which is like the very last alternative, produce this one. That's the odd. So we can expand this into multiple if and elifs and elifs and in that order, and it grows. So if we try this, we have odd printed because 5 is not less than 2. All right, 5 is greater than 2, so the yes is not executed. So it goes into the first else statement, and within the else statement it starts a comparison again. Is 5 mod 2 0? That is not true. If it were true, that even will be produced. Since it's not true, it moves on to the alternative, which is the odd, and it produces that. So let's change the 5 to 4 and see what we would have. Okay, we have even because 4 is not less than 2, so the yes is not produced. But in the first alternative, because 4 is divisible by 2, the even is produced, and that's it. All right, and that's how we do one liner, I mean, decision making. Okay, so there are some other examples you can try your hands on. And just as a way of recapping what we've done today, we looked at what scientific computing is, went through all the basics of Python, looked at the data types, and then also the conditions. And this is the end of day one. We are 4 minutes behind our time, but I think we'll still make room for some questions. So if there are any questions, if there's something you didn't fully understand, you can ask, and then we'll throw more light on it. Okay. And if you have a question, since there's a general question time, for the sake of our viewers who are also joining online via the YouTube channel, it's best you come to the spotlight and then ask your question. All right, Adam. Yes, please.
Yeah, hello.
Yes, we can hear you, Adam. Please go ahead.
Yeah, my question was on the list. You see, when you wanted to append a list,
Mm-hmm.
after appending the list, the new list goes to the last end of the previous list.
Mm-hmm.
So it will append itself to the last end of the previous list.
Mm-hmm.
What of when you want to insert the list at a particular index? So maybe you want to insert the list maybe at index 2. Do you have any ways and means to do that?
Yes, I think that was also explained in there. When you look at the example, we made use of the insert option to. Okay, so if you look at this one, so we inserted at the position that's index 2, this new name. So if we try this, instead of appending to the end, it places this at the second index. So the inserted name comes right here. Okay. And so it's possible to also do that rather than appending to the end. Yeah. So I believe your question is answered. So if there's any other question, okay, let me and so you can come to the front of the class and ask, or you can type it in the chat. So okay, so um, you said if the number is greater than 2 and even, will it produce both yes and even? Okay, so no, that wouldn't work. So like just as I explained. So just as I explained. All right. So just as I explained for the very top part of the decision making, all right? As long as the first condition is met, so at any point when the first condition is met, it breaks out of that whole um, decision making construct. Unless, of course, in just as in this case, even though this was met, this particular if statement was indented within it, so it's still continuing within that whole construct. But if you noticed from here, I explained that even if the two conditions are true, all right, at the very first instance when the condition is met, it is met, and so it goes out of the decision construct. Okay, and it's the same with the one liner. So let's try this. Let's say we have um, so yes, so we have this. So let's say we change this to greater than. So yes, if 4 is greater than 2, else even if 4 is divisible by 2, else odd. But the first criteria, we know 4 is definitely greater than 2. So we'll just produce yes, and that's all. We don't have the even added. Okay. So I hope your question is answered. Okay. So Doris, if your question is answered, you can just indicate a thumbs up. Oh, okay. All right. Sure. So any other question? Right. So, if there's no question, we'll be ending today's session here. This is day one. I know I mean, for some of us who have done Python before, this seems, very beginner level, but it's necessary we start from this point because we have, like I said from the beginning, we had over 91% of our, the participants who showed interest. I mean, those who registered, who showed interest, being very, at the basic level, at the very fundamental level of learning Python, or either they don't even have, I mean, they probably didn't even have any knowledge of Python and how to use it. So that's why we have to start from here and then we'll build probably to an intermediate level, hopefully. And like I said earlier, we've also shared the GitHub repository with you where you can access all the um, items that we are using for the class, the data we'll be using, the various notebooks, and then a host of other things. This is not updated, so as we move along the days, if there's a need to do any updates, I'll let you know. And also, again, I mean, for the sake of those who couldn't join directly, maybe because of the threshold that was set on the room, we also are sharing this directly on our YouTube page, so you can um, you can also get access to it. So if you go onto Meteo Data, you have the live video being streamed, and so you can share that with those who still would love to learn from the beginner level, and also you can share the notebooks with them, the GitHub repository. Let's try our hands on the examples we had in the notebooks, and then if you have any challenge, hopefully tomorrow when we meet, we'll be able to help you. If you can join in early enough, that would be better. Say 9:30, so that we can use that 30 minutes to address the challenges that you have before we move on to the session tomorrow. Um, so Dorcas, I believe I'm done. If there are no further questions. Hello, Dorcas. Yeah, hello, Dorcas. Okay. All right. So, I mean, I think maybe Dorcas is off her mic. So that's the end of today's session, and I believe we've enjoyed ourselves. So, I mean, we can show with a thumbs up if I mean we had something, or let's say our expectations were met. What we wanted to achieve in the first day at least was met. Okay. Oh yes. So I think Dorcas is back. So Dorcas, please over to you. I guess I'm done for the day. Thank you. So let me stop sharing then.
Thank you so much, Dr. Jeffrey. That was very insightful, enlightening, and I mean, it was worth it as well for us all. And I hope our participants did enjoy and did learn so much. So, this is workshop day one. We hope to see you again tomorrow at 10 a.m. But then the room will be open at 9:30 a.m. So GMT. So if you have questions, you can come in at 9:30. The facilitator will be available. Other mentors will also be available to answer all your questions. And we would also like to apologize to the other participants on YouTube who feel left out as well. We are sorry for the technical issues we had for you not being able to enter Gather Town. We hope for a better network. We hope for a better entry tomorrow. So we are urging, like the facilitator said, please kindly do solve the examples in the notebook and bring in your questions. So till tomorrow, kindly take care. And thank you so much for joining. Invite others as well. Now we can say bye.
Sure, but then also just a quick one. The room still remains open, so if you still want to stay and work, I mean, you can stay around and maybe work with somebody as a group through the assignments. That's okay. And but for the facilitators, I'm sure maybe some of them would be around. If you want to still interact with them, that's okay. And hopefully they would be. I mean, we would all be around again 9:30